Hello viewers, welcome back to my channel. So today's video is going to be in the topic of fusion power is coming. Nuclear fusion power is coming. So before starting this video, if you haven't subscribed my channel, then like, subscribe and share and press the bell icon to never miss an update. So let's start the video. So on February 8, scientists associated with the Joint European Tours (JET) fusion experimental facility located in Oxfordshire, UK announced that they had achieved a sustained fusion reaction releasing 11 megawatts of thermonuclear fusion power burning a deuterium tritium plasma mixture continuously for 5 seconds. The heating power being applied to the plasma was slightly greater than the fusion power released. So, while JET did not achieve the milestone of energy break even, it came very close. The power level of 11 megawatt was no more than the record that JET, which was built in the 1980s, set in 1997. But this time the burn lasted 5 times as long. So, three cheers for the JET team, but still one must ask, why is a tokamak that began operating 35 years ago still the best in the world? Or more broadly, why has the progress developing fusion power been so slow? So it is very important question. It was just over a century ago that Sir Arthur Eddington, who had made observations proving the truth of Einstein's theory of relativity in 1919, released that the mass lost when hydrogen nuclei fuse to form helium must release a stupendous amount of energy in accord with Einstein's famous equation E is equal to mc square, and that this must be the mysterious source of the power that light of the sun and all the stars. Eddington immediately saw the potential practical application of this discovery. In a speech to the British Association for Advancement of Science in August 1920, he said, if indeed the subatomic energy in the stars is being freely used to maintain their great furnaces, it seems to bring a little nearer to fulfillment of our dream of controlling this latent power for the well being of the human race or for its suicide. The idea of turning matter into energy remained speculation. That was until Meitner, an Austrian scientist who had fled the expanding Third Reich to Sweden because she was of Jewish heritage, reviewed data sent to her by former Berlin collaborator Otto Hahn and released that he had accomplished nuclear fission. Meitner shared this insight with her nephew Otto French when he came to visit her from Denmark for a Christmas party in 1938. French then told his boss Niels Bohr just before the latter sailed for New York to meet with Leo Szilard, Enrico Fermi, and a bunch of other refugee and American scientists for a conference. They immediately realized its significance before the conference was over. This duplicated Hans experiment, and shortly afterwards, Szilard had his friend New York physicist Alexander Sack hand carry a letter with Einstein's signature on it to Franklin Roosevelt to alert the president as to what was now possible. FDR quickly got the drift. So, what you are saying, Alex? He reportedly replied, is that you don't want Hitler to blow up us. Sachs noted, thus was born the Manhattan Project. Nuclear fission works by splitting the heaviest elements into middleweight ones using neutrons as projectiles. It is thus much easier to do than fusion because neutrons, being neutrally charged, are not repelled by target nuclei while making light nuclei fuse requires overcoming the strong mutual repulsion of positive charges. Moreover, each fission reaction releases two or three more neutrons, enabling a chain reaction where each fission sets off several more. Thus, fissions became the basis of the wartime atomic bomb program, and not long afterwards provided the path to control nuclear power, enabling first nuclear submarines in 1954 and then starting in 1957 commercial nuclear power plant as well. Yet fusion was not forgotten. Using fission bombs, one can heat and compress the mass of fusion fuel to high enough energy, temperature, and pressure to set it off, with a resulting energy release thousands of times greater than the fission explosion. By the early 1950s, such hydrogen bomb weapons were a world dominating reality, but could not this immense destructive power also be, as Eddington said, put to use for the well being of the human race instead of just its suicide? It was clearly worth a try. While fusion of ordinary light hydrogen, as occurs in the stars, requires reactor far bigger than any human can build. The heavy isotopes of hydrogen, deuterium, and tritium react much faster, making both hydrogen bombs and controlled fusion reactors possible. Deuterium is present in Earth as roughly 1 out of every 6,000 hydrogen atoms, but even that small fraction packs a big punch. If burned in a fusion reactor, that tiny fraction present in 1 gallon of any water, fresh or salt, can release as much as energy that obtained by burning 350 gallons of gasoline. For all practical purposes, controlled fusion means infinite energy. So, starting in 1949 in Britain and then in the early 50s in the US and USSR, top secret programs were begun to try to create controlled fusion reactors. The US and British program were only secret from each other. The Soviet, through their excellent espionage network, were well informed about the progress of both. In fact, the head of the Soviet program, Igor Kurchatov, was better informed about the British program than the British themselves were. So much so that in 1956 he even came to the British Harwell lab to deliver a surprise guest lecture. Without revealing his source, he then generously explained a mistake that someone might make: the measuring number of fusion reaction occurring within a plasma. Unfortunately, the British did not listen and impressed themselves greatly a year later when, in response to Sputnik, they declassified their fusion program with a accompanying announcement of successful results that proved to be fiction. On the positive side, however, the British announcement led to the declassification of all the controlled fusion programs. This was followed by the wonderful Atoms for Peace conference held in Switzerland in 1958, where all male contingents of American fusion researchers had the pleasure of spending many long hours chatting with the vivacious young women of the Soviet Translation Service, all of whom evidenced an intense interest in experimental and theoretical physics rarely encountered among college girls back home. Even with declassification, however, the Soviets remained the best informed of all the fusion players. So, knowing fully the flaws in all the diverse Western approaches, they were able to devise a better one. This was the tokamak, a name deriving from the descriptive Russian acronym for toroidal chamber magnetic. It would require getting too technical here to explain why Duffnet shaped tokamak worked much better than the magnetic mirror. Z pinches, theta pinches, and stellator being pursued in the West. Suffice to say that it did, but The mid 1960s, the tokamak Soviet champion Lev Artsimovich was announcing results that were so much better than those achieved elsewhere that no one believed him. So he did the unthinkable. He invited a team of British scientists to come to Moscow and observe and measure the results of experiments on his T3 tokamak using their own instruments. In 1968, they did so and confirmed that all of Artsimovich's claims were true. Tokamak fever swept the West. Meanwhile, the Soviets continued their program, advancing from the seminal T3 through a series of ever larger machines, including T4 in 1969, T10 in 1975, and the superconducting T15 in 1988. As a result of the tokamak fever program supporting alternatively approaches to fusion, including not only stellarator mirrors, toroidal jet pinches, but novel ideas taking advantage of the self-organizing properties of plasmas, such as spherocomac and field reversed configurations were staffed for fun. While few Storator fanatics continued to hang on in Germany, the last major old guard competitor to the tokamak was the magnetic mirror. But after spending over $200 million to complete the MFTFB flagship magnetic mirror at Livermore in 1985, the Department of Energy scandalously cancelled the program before the machine could even be turned on. But if the fusion program was dangerously narrowed to one major concept, that approach the tokamak advanced vigorously. Driven by spirited international competition with a workable approach in hand over the next 3 decades, the actual amount of fusion power released in the experimental tokamak grew a trillion fold. However, this victorious march towards controlled fusion was held dead in its tracks when the bureaucrats controlling the major fusion programs got together in the mid 1980s and decided that such competition was wasteful and stressful. Wouldn't it be better, they reasoned, if instead of competing with each other to build more powerful tokamaks, we all got together one on a single big machine? They decided it would be and called it International Fusion Test Reactors, or ITER. Fusion had made steady progress from the 50s through the mid 90s, driven by a lively competition between the US, European, Soviet, and Japanese programs. Through the national programs are a shadow of their former selves, and ITER continues to move ahead at the speed of continental drift. Something else is going on. A breakthrough has happened through its dramatic and rapid development of reusable launch rockets. Elon Musk's SpaceX company demonstrated that it is possible for a well run, lean, and creative entrepreneurial organization to achieve things and do so much faster that were previously thought to require the efforts of major power governments. This has hit observers of the fusion programs like a bolt from the blue. Could it be that the seemingly insurmountable barriers to the achievement of controlled fusion, like the barriers to attainment of cheap space launch, were not really technical but institutional? As a result, a whole raft of innovative private fusion power startups are now getting funded. Fusion is an unlimited source of energy, but there is an even greater power in the universe: human creativity. Fusion will give us wealth. So that's all about this video. So if you like my video, then like, subscribe and share, and press the bell icon to never miss an update about the research work and new discoveries going on worldwide. Thank you.